Hey everyone, we're going to just do an introduction to the complex plane. Basically, you have an x and y axis. The x-axis is called the real axis, and the y-axis is called the imaginary axis. A complex number can be written in the form of, we're just going to call it z here, equals x plus y I. So, basically, you've seen this before, but you probably have seen it in the form of a plus bi, or a plus or minus bi. All right? So, especially when you did your quadratic formulas in Algebra 1 and 2. So, basically, this is called the real axis because you could put, for this point right here, we could say, and I'm going to be erasing some of this, but z equals x plus 0i, which just means c equals x. And similarly, we could say this point right here is z equals 0 plus yi, which is just basically z equals yi. All right? So which is a pure imaginary number. And remember, you have your real part and your imaginary part. Okay, so that's basic stuff that you probably have seen before. Now to plot it, we're just going to plot it like this and call it z. Now what we also have in addition is the length of this on this figure 2 right here. So if you notice, we're going to call this the magnitude and or modulus of z, and it's the distance from the origin to the point in the complex plane. All right, so basically it equals this. And if you notice, what is this? We notice this is what r is, our radius. We've seen this before. So now we're just calling it something different. Instead of r, we're calling it the magnitude of z, which is the point from the origin to the point in the complex plane. All right? We also need to know the conjugate. Remember when you had a plus bi, the conjugate would be a minus bi. And when you FOILed this out, you got a squared plus b squared. Or you got it in the opposite way. So whatever you get first, if you got minus first, then the conjugate would be the plus. And you still get the same form because this is the a squared minus b squared form. But when you square the I, so when you have a squared minus bi squared, I squared is -1, so that's what changes it to the plus here. All right, so this would be a squared plus b squared. All right, but now instead of doing the a and the b, we're going to be doing the x and the y. So basically we have x, if we have x plus yi, same thing as the b thing, then the conjugate would be x minus yi. And so we have that, that's called the conjugate. And we can write this as z equals the square root of z times the conjugate of z. This would be z, and this would be the conjugate of z. All right, so that's another form. Anyway, that's basically the information on that. And what we're going to do is go ahead and try to show you what this looks like with some examples on the next page. All right, so basically we want to convert a complex number from a rectangular form to a polar form. So from our previous videos, we already know that x equals r cos of theta, mainly because cos of theta equals x over r. And similarly, we have y equals r sine of theta. Same reason. Okay, and we already discussed this as well. Anyway, so there's what we're going to use to convert with. And we know that Z equals X plus yi. That's what we're calling it. So our X is R cosine of theta plus our Y, which is R sine of theta, and then we have the I. Now I can pull out the R, and I get R cosine of theta plus, and the R is being pulled, I'm pulling this out here. I'm going to put the I in front of sine of theta. It just looks better that way. So I put the I in front, and I did the highest common factor and pull out the R. So basically, this is your polar form right here. This equals your Z. All right. Okay. And we already talked about that R is basically the Z, which is the distance from the origin to the point, is really your R. So let's do an example. We have Z equals the square root of 3 minus I. So this is like your X part, and this is like your, we'll just do minus Y I part. So your X is square root of 3, and your Y is going to be negative 1. Okay, I'm just pulling it, so that's your Z. All right, now, so if I kind of look at this, and I plot it in here, my X is square root of 3, which is a little smaller than 2, and my Y is negative 1. So I'm going to go a little smaller than the square root of 2 and negative 1. So let me put this in blue. So there's your point right there. All right? Now, what we want to do is convert this to polar form. So what I want to find is my R, because we need to find R here. And we already know what R is the same as absolute value of, or the magnitude of Z. So basically, R equals magnitude of Z, which is square root of X squared plus Y squared. So we get R equals square root of 3 squared plus negative 1 squared. And R, therefore, is going to be, this is square root of 4, which equals 2. That's my 2. So I also know that, I put imaginary axis here. I also know that I have my X and Y and my R's, so I know that sine of theta is Y over R. My Y is negative 1 over 2. And cosine of theta equals X. My X is square root of 3 over 2. Well, the angle where both of these are true, where this is true, it's in quadrant 4. Again, we already know we're in quadrant 4. Is theta has to be 11 pi over 6. Oops, why did I do that? All right, so theta has to be 11 pi over 6, because that's where this is true. All right, so now when I write this, I'm going to write this as Z equals R. R is 2 times, I'm just filling this in now, cosine of 11 pi over 6 plus I times sine of 11 pi over 6. Now I'm going to do another video with a lot more examples of this, but this is just a little introduction. So if you don't get this right away, maybe watch the next video. This is all we're going to do, is a bunch of these type problems. I do want to go over converting from polar form to rectangular form as well. So we've given it in polar form, and this is your R, and I want to write this in rectangular form. So basically an x and a y. And if I write this in that form, basically I get, we're going to write, we have to plot this too, so we've got to plot this. So let's plot it first. All right. This is not good. All right. So this is imaginary axis. This is the real axis. So x and y. So my angle is 30 degrees. And we're going up by 2. So I'm going to go up 2 units. This is 2 units. And this would be 30 degrees here. So this is your z, which equals that. Okay. So basically what we're going to do is just write it out. If I do polar coordinates ways, and this is what you want to get used to, this would be 2, 30 degrees. And now this is your r, theta. And you already know how to do this. So basically, it's going to be 2 times cosine of 30 degrees is square root of 3 over 2. And sine of 30 is 1/2. And then you put the I here. So we're going to get square root of 3 plus, because this cancels here, also cancels here, plus I. So that's your rectangular form. And you're just going to call this z equals this. So z equals square root of 3 plus I. Again, if this is a little too fast, we're going to do a whole slew of problems on this on another video where this is all we're doing. Okay, thank you and have a nice day. Bye-bye.